In this video, we are going to learn about determinants. Determinants are an important tool from linear algebra that, among other things, help us determine which matrices have inverses. You might have also seen determinants in other courses. For example, the Jacobian is a determinant, and you might have also seen a determinant definition for cross products. Determinants are going to be defined recursively. What that means is that in order to compute the determinant of a 3 by 3 matrix, we're going to be able to need to compute the determinant of a 2 by 2 matrix. And if we want to compute the determinant of a 4 by 4 matrix, we have to be able to compute the determinant of a 3 by 3 matrix, and so on and so forth. So since this is a recursive definition, we have to start by learning how to find the determinant of a 2 by 2 matrix. The determinant of a 2 by 2 matrix, and let's call our matrix A, is going to be denoted this way. So we're putting vertical bars to the left and right of our matrix A. And we might also write out the determinant like a function using the name det. And for a 2 by 2, this is what we're going to do. So here's my matrix with entries A11, A12, A21, and A22. We're going to multiply the elements on each diagonal, so A11 times A22, and A21 times A21, or A12 times A21, and then we're going to subtract. So we multiply these and subtract the product of these two elements. Let's do a couple examples of 2 by 2 determinants before we move on to larger determinants. So here's my matrix A. It has 2, 6, and minus 3 on the columns. Next, we'll compute the determinant. I'm using the vertical bar notation, and this is another common notation. Instead of using the brackets like we normally do for a matrix, if I want to say I'm taking a determinant, I replace the brackets with vertical lines. So to actually compute the 2 by 2 determinant, we take the product of 2 and minus 3, and we subtract the product of minus 1 with 6. Okay? So 2 times minus 3 is minus 6. Minus 1 times 6 is also minus 6. So when we subtract, we get 0. Let's do another one. This matrix is pretty similar to the matrix A. The only thing that's changed is this 3 here. We started as a 6. So the determinant of B, again using the vertical bars, is the product of the main elements on the main diagonal, 2 and minus 3, and you subtract the products of this diagonal, minus 1 times 3. So here we get minus 6 minus negative 3. Overall, we get minus 3. So something I want you to think about before you move on is the comparison of these two matrices. So do you notice anything about the columns of the matrix A? How do those columns compare to the columns of B? And here's a big hint for you. This has something to do with linear independence. So think about linear independence. Think about the columns. And then think about the values of our determinant. So here we have a 0, and for b, we got something that's not 0. We got -3.